GCSE require practical on investigating how force affects extension. So here we've got a spring that's attached to a clamp, and what we're going to do is attach masses onto the clamp and measure the extension. What we're going to do here first is measure the original length of the spring, which I've got here is 2 centimeters. Once I've recorded the original length of the spring, I'm going to apply the first mass. Just wait for a second until it stops. Once it stops, I'm going to record the length of the spring, which now I've got is 2.5 centimeters. So I'm going to minus the final length and the original length to get my extension. So my extension is 5 centimeters. So once I have an extension, I can calculate the spring constant by using this equation, which is Hooke's law, where F is equal to KE. So force is F, K is spring constant, and E is extension. Rearrange this equation to make K the subject, where I've got K is equal to F over X. But in this case, my X is my extension. What I'm going to do here, I'm going to carry on applying masses to get various sets of results. So here I'm going to apply my second mass, and here I'll record the next length, which is 4.5 centimeters. So minus that by my original length, which was 2. So I'm going to have 2.5 centimeters as my extension. Once I've got various readings, I'll be plotting a graph of F over extension. And where my gradient is going to be equal to my spring constant, which is K, which is shown here. So what has Hooke's law stated? If it's a straight line, it follows Hooke's law, as it will return to its original length when removing the masses. But when it starts curving off, this is where it disobeys Hooke's law, and this is where we call it the limit of proportionality, and this is where it becomes plastically deformed.